Hey guys, and welcome to Functional Print Friday. So I'm over here at my lathe today and I've got my 3-jaw chuck on here. And it's a great chuck, I love it, but it's not a 4-jaw chuck. And I need a 4-jaw chuck for the job that I'm going to do on the lathe today. And I'm dreading changing the chuck out because every single time that I have taken a chuck off this machine or put a chuck onto this machine, I have gently scratched the spindle nose on the lathe itself. You see, this chuck is interchangeable. And it aligns with the spindle on the lathe by a tapered nose on the spindle back here. And there are 6 studs that are attached to the back plate of the chuck that go into bores on the spindle. And then there's like cams that draw it in or up onto that taper. The problem is those studs are really close to the taper, and it is really hard to line up all 6 and get this guy on there without touching the taper on the spindle. And the worst thing is that taper is, again, what creates the precision between the lathe and the chuck. So scratching it up is not great. Let me pull this off and I'll show you what I mean, because I think I have an idea of how we can fix this with a 3D print. Okay, so I've got the chuck off and I set it here on a piece of plywood, and actually I keep this plywood underneath the chuck when I'm putting a chuck on or taking a chuck off. So if I slip and drop it, hopefully it doesn't damage the bedway on the lathe. And you can see now what I'm talking about. So here's those bores. There's 6 of these bores that these studs go into, and you can see this sort of half moon shape is what these cams are turning and pulling this guy in on. But look how close they are to this taper. You can see there's hardly any clearance at all between where the stud goes in and where the taper on the spindle is. And in fact, in that very spot, you can see some scratches that I've put there, hopefully. Yeah, that's I tried to stone it off with a precision ground stone. So there's nothing that's raised there, so it should be okay. But you can see that's what's happening. And the scratch is right there where the hole is, because it's really hard, again, to line up all of these studs and get them into these bores without any of the studs touching the spindle. Because remember, they go all the way around. So it's not like I can just be way high on this one and then slowly come down and go in the bore. If I'm high, the ones at the bottom are going to contact the underside of the spindle taper. So, this wouldn't be so bad if the chuck wasn't really heavy, and this one actually isn't too bad, but the 4-jaw is incredibly heavy. In fact, let me go grab a scale. Let's weigh these chucks and see how heavy they are. All right, hopefully if I set the scale sideways here, you guys will be able to read the display, and I'll still be able to get something onto the scale. So this is the 3-jaw. This is an 8-inch chuck, and I don't think this one's too bad. It's still hard to hold steady up there. Okay, yeah, it weighs 47 pounds, so it's by no means light. And I can lift 47 pounds, no problem. The problem is lifting it and holding it in a very precise fashion to get those studs into those bores without touching the spindle. The real challenge, though, is the 4-jaw. Let's see what this guy weighs. All right, here's the big boy. This is the 10-inch 4-jaw. See if I can get that on there without blocking the screen. 68.4 pounds, so just shy of 70 pounds. And again, I can lift 70 pounds. I've gotten this on the lathe on and off 2-3 times now. The problem is holding it in a very precise location for an extended period of time. It takes like 10 seconds to get everything lined up and put on in place, and then you still have to hold it. Even once it's in place, it's not going to stay there. It'll still fall out of there until you actually lock at least one of those cam lock studs. So then you're trying to force it onto the spindle with your one hand, holding back that 70 pounds, and then trying to get one of the cam lock studs tightened with your left hand. God forbid you drop the wrench. Now you're taking this thing back off, lining it back up again. It's a pain. I know a lot of shops on particularly larger lathes where it's not even possible to lift the chucks, or not even remotely possible to lift the chuck and hold it in place to get it on there. Use like an overhead crane or something like that. I have a much simpler idea. I think we can make something that's going to line this chuck up precisely and make it a lot easier on the back to get these things on and off. Let's go back over to the lathe. I'll show you what I mean. Okay, so the lathe has these precision ground surfaces on it that the carriage rides on and that the tailstock rides on. If you notice, the tailstock uses the inner one, so this V here and this flat here, and the carriage uses a flat over here and a V out here. What if we design and 3D print something that uses those same ways? So maybe this flat one back here, because these, by the way, the tailstock one does not go all the way. It stops shy of getting up here to where the chuck is going to go. So really that's out of the question. We can't use that. But the other one, the other set of ways goes all the way to the headstock on this lathe. It does that because I guess if you're cutting really close to the spindle, maybe turning between centers, the carriage has got to be able to get all the way over there. So what if we use those? What if we design something that slides on those, that is the perfect height to come over here, just set the chuck down onto, and then slide it into position? It's obviously got to be dead on, but I mean, I think we can get pretty darn accurate with a 3D print, even one this big. I mean, this is going to be a big print. That's a fair amount of height between. Well, let me grab the tape measure. Let's see what we're working with here. Maybe actually we can't do this. Let's check measurements first. Nah, we're good. We're well within the build volume of actually all of my 3D printers. This is going to need to be at least 7.5 inches across or under 200 millimeters. So we're good. We're going to want to run a little bit past probably, but we're still good. And vertically, we're nowhere near running out of space. Yeah. So it's not like we need to actually go all the way to the center of the spindle, but even if we did, that would still fit. So, all right, so we're going to need a bunch of measurements to be able to make this even remotely precise. We need to know, in relation to the center of the spindle, exactly where this V sits and exactly where this flat sits in at least two-dimensional space. Not necessarily three-dimensional space, but we need to know like all of the distances to be able to relate these faces to the center line of this spindle to be able to do this. And actually I think we can cheat a little bit because we have the exact center of the tailstock should be the same as the center of the spindle. So we can put like a pointed center here in the tailstock and probably take our measurements from that. Let me grab a center, I'll show you what I mean. Okay, yep, so now we can take all of our measurements on this end. It's going to be a lot easier to measure from this side. And we just need to figure out, this represents the center line of the spindle now, the point on the center. And we need to figure out what that is in relationship to all of these other surfaces. And I think we'll draw all those in CAD and then build our design from that. Maybe do a test print to make sure that we are actually at the center point of the spindle first. So I'll spare you watching me take all these measurements because I'm not even sure how I'm going to take all these measurements. Probably have to do some sort of like precision block stack up from maybe the flat on the lathe. And same thing from the top of the V, maybe. There's like a small flat here on the top of the V. And I just get the dimensions of the V from that flat. I'll figure it out. I'll bring you guys back once I have all the measurements and I get a start on this in CAD. All right, guys, and here's where I'm at with this. And this probably doesn't look that impressive, but remember, what we're trying to do at this point is establish the precise distance between the center line of the spindle on the lathe, and this is meant to represent the spindle. This line here on our green axis represents the center line of the spindle. And what we're trying to do is capture in a very precise way where each one of these precision ground faces is in relationship to the center line of that spindle. So I actually drew both sets of ways, both the inner one that the tailstock rides on and the outer one, because I used the ways in the center to establish some of the measurements and then measured from these faces to these other faces in at least one instance. I forget, kind of turned around here which way is which, but one of these I had to stack blocks. Oh, I know what it was. I stacked blocks between the two flat surfaces. Measured from the edges of these to get their position in relationship to the center line of the spindle, and then just took a set of calipers and measured from the edge, like this edge face here, over to the edge face on our V-way. And then I measured with a piece running across the top what the height difference was between the flat on the V-way and the flat face of the flat portions of our ways. So at this point, I mean, I'm confident that it is at least as good here in CAD as I measured it, but I think the next thing to do is actually print a test piece and just, kind of see where we land. So if I unhide here, I have got a test piece, and I will bring this over. Let's see if I grab on to like this piece down here and bring this over so I can give you guys an idea of what I hope we're going to be able to do. Is I'm going to print this, and then I want to be able to bring it over to the lathe, and it's not exactly on there, but you guys get the idea. This piece should sit on this V-way, and I have a notch up here in the top just to make sure that we are not contacting on that top face at all, which is going to throw off our measurement, because we want this to rest on the faces of this V, and then our flat on this way over here. And I've got clearance to make sure that we don't touch this V-way here. And if we're dead on, we should be able to bring this small hole up here in our test piece over to the center line of the lathe, and it should line up perfectly. So I am going to print this test piece, and you guys will see me back at the lathe. All right, and here is our test piece fresh off the printer. Let's see how we did. Got that backwards. We need the V on this side. Let's see, does it even fit on here first? Yeah, that looks good. Probably should have gone a little bit taller with this because it's kind of rocking around a little bit. If I push down on it, it seats on the, yeah, there we go. If as long as I keep downward pressure, it stays seated on that V-way. And we look like we're pretty close in the back, but this is what matters up here. We are either dead on or we are really close. Okay, I've got it cranked up until I made contact, and I'm just trying to look around from every side. And I don't actually see, we might have a tiniest little bit of gap on that side. I think everywhere else, it looks like we're touching. Yeah, top to bottom, I would say we're definitely good. There might be the tiniest gap on that side. I think there is. I think we have probably maybe 0.02 to come over in that direction, and we're dead on. So I'm going to make that adjustment and start on the actual design for the sled itself, and I'll bring you guys back. All right, so I have modeled just a cylinder here for an approximation of the chuck. I mean, there's really no point in modeling all of the details of the chuck. All that really matters is that we have the outside diameter accurate, and I have modeled a piece down here for our sled. And toyed around with a couple different options. What I ultimately decided was that having just a single arc coming across that cleared our center V-way was probably going to give us the highest amount of strength. Even though we have a little bit more room for material down here, I don't think it's actually going to add to the strength. I think sort of that arc shape across and then dropping down just shy of where the V-way is probably going to be the strongest design. So I did throw some lettering on here, and this is the model number of the chuck. I may end up tweaking that. I just kind of put that on there as a test, and I added some accents here on the side for, I don't know, there's other than the fact that I thought it looked kind of cool. There's no functional purpose of this, but I thought it just, you know, set that front face out a little bit, and why not, right? So let's print this and see how it fits. Okay, I've got the 4-jaw chuck on here, and I'm sad to say that I think I did actually touch the spindle nose with 2 of the studs putting this guy on, but hopefully that is the last time, because I've got our test piece for this chuck, and I'm not super happy with how the font came out on this. I think I made a mistake in not printing that face down and doing it in 2 colors, like for example we did on the carriage lock. I think we're going to get better text if we do it that way. Also, it just seems a little big to me. It's readable. So, but let's see how this guy fits. Oh, that's looking good. Yeah, there is, I might reduce the size of the gap a little bit. I feel like if I slide this guy off of here right now, it's going to probably drop. I don't think it's going to drop down enough that the studs can hit the spindle, but I don't think they're going to be quite lined up. I'm also not happy with how we're actually just shy even of covering up to the edge of the bed, where there's probably like a 1/16 of an inch sticking out there. I think we're going to make this bigger. We'll go just wider on this and maybe taper it down at the bottom. Maybe even go a little bigger up at the front. And I don't like the way the text came out. So let's come up with this to tighten up the clearance a little bit between the chuck and this surface here. Let's try out different lettering and let's make another test piece. Okay, I stopped this one before it went any further because I really just want to see how our clearance is, and I really wanted to get this guy off the bed to see what the text looks like, and the text came out amazing. I like it this smaller size and in the two-tone, and with this as the face that prints down on the bed, that just looks 10 out of 10 to me. I am super happy with how that came out. Hopefully the camera's picking that up. So let's see how it fits. Oh, and yeah, I think our overhang on the back is much better now. Yeah, so I came up too high. That's okay. I kind of feared that might be the case, that maybe I was coming up a little bit too much. So I think I'm going to shoot for halfway between where the original one was and where this guy is. Because this is... Yeah, actually, I can kind of force it under there. I don't want to get it stuck. It just starts to go under, so I'm close. Again, I'm going to split the difference between the height of the first one and this one. We're not going to make any other changes because I'm happy with everything else. And let's see how we do on the third try. All right, that was a crazy long print, but I am really happy with how this guy came out. This took just shy of 24 hours to print. I think it was 23 hours and 10 minutes or something like that. But it came out gorgeous. It's actually really quite heavy. This was almost a full kilogram of filament, but that's okay. I'm happy to spend it on this if this works, but let's see if it works. I think we are dead on. I don't see any light underneath there. It barely moves if I try and rock it, like maybe a thou. But it does clear. I'm not hitting, and it's not rubbing either. Let's, oh, how's our width? Yeah, so I ended up going a little bit wider, or I should say a little bit taller, since it was printed with this face down, than the chuck, which, again, took a ton of plastic and a ton of time to make. But I'm confident now that we have plenty of surface area here to land this chuck on, both when I'm removing it, as well as when I'm walking over to the lathe and setting this guy down. So, moment of truth. Let's actually try taking this chuck off and see if this works. All right, I've got you guys set up directly between me and the lathe here. Hopefully I'm still gonna be able to reach in and do this, but I wanted to give you guys a good view at how well this either does or doesn't work. So first thing we gotta do is unlock all of these cams, and there are 6 of these. So to do that, I am just gonna drop our wrench in here, and these just turn until it kind of slides into a notch. Normally when I'm doing this, I'd be super nervous and I'd be absolutely standing right where I have you guys, because as soon as this guy loosens up, if it's not, sometimes it'll stay on the taper and I actually have to give it a knock with the mallet. But if it wants to fall off, there's nothing stopping it. Those studs are not going to keep it in place. It's just going to fall right down onto the bed of this lathe. Now we have our nice 3D printed piece in there, which should basically play catch. Oh, hear that scraping? We're actually hitting on our 3D printed piece now. It's clearing it. I can hear it scraping. I bet you one of these surfaces either has a little bit of a burr in it. Actually, this one feels like it has a little bit of a burr in it. Yeah, so one of these probably has a high enough burr that it's digging in, because there's nothing else sharp on here, and it sounds like something. Yeah, we'll see when we get it off, but it sounds like something sharp. This might be the last one. Oh yeah, I could feel the chuck shift. So we have a slight gap opened up here now, but I didn't really see the chuck drop. Oh, that is like butter. Let me get you guys off the tripod. All right, guys, I am really happy so far with how this is working out. I didn't see any give in this at all. I was a little worried about the sheer weight, 70 pounds of mass up here, how this would do supporting it. But I think, you know, here's our test piece. You can see how dense we are on the infill and how strong this infill is. And we did 4 walls on this. I think I'm worried for nothing. I think the chuck could probably weigh 170 pounds, and I doubt this guy would actually have any give to it, especially over that distance. It is a little hard to slide. If this was made of steel or cast iron with a little bit of oil on here, and there is a little bit of oil on here, this guy would probably slide even better. There is a little bit more friction between the plastic and these ways than there would be if it was metal. Now that said, I mean, that friction's not going to do any damage to our precision ground ways here, which is really what I care about. If we ever actually wear this piece out, I can clearly just make another. But I just had a thought. You know, so this is probably where I would position this, or maybe even a little bit further over if I was walking over to the lathe with the chuck, but I don't even need to slide this guy over. I mean, I can, so see one-handed here. Let's see how hard this is to push. Yeah, it's actually not bad. I mean, it takes some effort, but it's doable even with just one hand. But I think we could use the carriage to push it on. I think once we were lined up on the holes, and we can turn this. Here, let's move this so we're not lined up, because that's kind of like cheating. We know we just came off, so we know it's lined up. And I'll shift this to high, make it easier to turn this. Okay, so this is more realistic now. Let's pretend I walked up, I set this down on here. We're not lined up over here. Let's bring the carriage over. You guys see what I'm thinking here? I bet you we can force this over with a lot of control with this hand wheel. Let's see. We're gonna hit. I do not want to crash our carbide insert there into the chuck. Nope, we're gonna hit down here first. Oh yeah, I can't, sorry. You get so much gear reduction in turning this, and you already have the friction of this sliding. I hardly even notice the difference of the carriage pushing this guy over. So get close. Oh, that's a perfect check to make sure we are, yeah, we're not touching that spindle nose. And if I line this guy up now, and then very gently oh, look at that. Like it's meant to be. Yeah, right on there. And now, you know, the beauty of this is supporting it as well. I can take my time, you know, coming around here, carefully grabbing my wrench for the cam locks on the spindle to actually draw this guy in on that spindle rather than standing here with one hand trying to hold the chuck onto the spindle and the other hand trying to turn at least 2 of these to keep this guy from falling off. Now I can back this off. I mean, you can see we could just leave this chuck sitting on that sled all day long. So, all right, well, I already feel like we're almost done, because this is the chuck that is super heavy, and that it's like, you know, it's almost impossible for me to get this guy on or off without hitting those studs against the spindle nose. But I do want to make one for the 8-inch 3-jaw chuck as well. All right, guys, might have gotten a little bit carried away. Pretty much filled up the whole screen here with pieces. Not only did I design the sled for the 8-inch chuck, you know, with pretty much the same parameters that we used for the 10, aside from the difference in the OD of the chuck, but I also designed sort of a tray piece, sort of just a blank with a little bit of an inset here. That what I'm thinking we can do is, once the chuck's already on the lathe, I can set this guy down on the ways, slide it over underneath the chuck or underneath the front of the chuck, so that when we're chucking in large pieces of material, we don't risk dropping them on the bedways either. And it might make kind of a neat tool tray down there for complex setups as well. Maybe for using collets, you know, it just is a nice place to set down the different size collets and wrench as we are working, and then I guess pick it up and set it down on the workbench, and then bring it back when we are ready to swap out the collet size, or, you know, flip the workpiece around. I'll print both of these, and I will bring you guys back, and I'll meet you back at the lathe. All right, so our 8-inch one is done and it looks beautiful. I want to get the 8-inch chuck on here and be able to test, or really we can use this to put the 8-inch on and we'll make that our test. But I just carried the 10-inch chuck off of the lathe and you can see there are scratches on here. I think there's just a raised burr on the chuck over here. So I'll have to go with a file just kind of around on these corners. Yeah, this one's, there's definitely a raised spot right there on this one. There's probably a raised spot on all these and one of them is just high enough to scratch this, or this one. This one, as it comes around, it's cosmetic, it's not going to do any harm, but I would like to resolve that if I can. But something I noticed carrying the 10-inch chuck over here is when I would pick this guy up to put it on the lathe before, I couldn't have a hand back here, because if I have a hand back here, there's no way for me to actually put it on the spindle. So I was having to pick this guy up with sort of one hand underneath a chuck jaw and then one hand kind of underneath. Now, because we're just picking it up and setting it down on our sled, it's a lot easier to carry this because I can put one hand still under the chuck jaw and one hand right in the back of the chuck like this. So it's way easier to carry. I didn't even think about that when I did this. All right, what do you think? Are we gonna be 2 for 2? Bring the carriage over. A little hard to see the lineup. You guys are kind of in the way. Oh, look at that. And right on. And I can back off the carriage now. I guess the true test is going to be once I lock these. Just lock 2. Oh, I can already, I can't, we're already not hitting this, so I think I'm answering my own question here already, which is, can we slide this out once the chuck is in place? 2's enough to hold it. Oh yeah, no problem. But I already know there isn't any extra play in there because this guy pushed right on, no problem. All right, that leaves us with one final thing to test, and that is the tray that I also designed. And this guy came off the printer, super nice. Really happy again with the lettering on this. The only thing that disappoints me on this one is I should have gone deeper with the tray, this recess here on the top. I was afraid of thinning out this cross section anymore. I didn't want it to be, weak. But holding it in my hand and seeing it, I mean, I definitely could have gone probably at least a 1/4 inch deeper with that inset and we would have been just fine. This is printed, by the way, at the maximum build volume height of the X1C or P1S. And it could do with being a little bit longer. I think it's going to be okay. But so if I drop this guy down on here, first of all, our fit is very good, which I would expect. It just follows the same design as the sleds for the chucks. And we've got plenty of overhang to protect everything. But I would probably position it, well, right about there, actually, if I was chucking a part in here. And it's decently long. If I had the build volume, I'd probably go another 2 inches, maybe even 3. Just to make sure that everything on the lathe was covered and protected while I was chucking a piece up. And, sort of acts as a tool tray as well. Well, so that's a little big, but, for other smaller pieces, particularly things that roll around, they're not going to roll off of this like they would just a piece of plywood. So if I had a couple things up here, while setting up, none of these things, again, are going to roll off of here because we do have that lip. All right, well, that guy might. So that's something, I might actually reprint this with slightly taller walls on this, but overall happy with this piece as well. And this one, just because of the, even though it's a smaller print in volume from this end, because of the height, this was a full day as well. Every single one of these parts took a full day to print, both well, with the exception of the test pieces, but the full size 10-inch sled, the 8-inch sled, and this tray, each of them took 23 hours and some odd number of minutes to complete. Well guys, I am super happy with how these came out. This 100% solves the problem I had with getting chucks on and off this machine. without damaging that spindle nose. And it's also made it easier to carry them over to the lathe and to carry them off of the lathe as well, since I'm not stuck having to try and have one hand underneath the chuck and the other hand kind of grabbing one of the the jaws on the chuck. Now I can grab it through the spindle hole or through the through hole in the chuck on both ends, walk over, set it down on that nice firm surface, and then push it into place with the carriage. So, what else are we missing here? Obviously, we've got a tool tray that also acts as sort of a protective piece that when we're chucking work into the lathe and taking work out. We've got sleds for each one of the chucks that I have on this lathe. What else are we missing? What else could we leverage the dimensions that we have here to quickly make some other accessories for this lathe? The one thing that I did have in mind is for setting tool height. So on a lathe, you want the height of the tip of your cutter to be exactly in line with the center line of the spindle. And I typically do that by just rotating this guy around on the quick change tool post and visually lining up the point of this insert with the point on a center in the tailstock. And that gets it close. It's probably within 5/1000 of an inch, maybe even closer. But I know it's not exact because oftentimes when I'm making cuts, I can see that I'm not on the center line. I'll end up with like a little nub still sticking out of the material, even though I thought I was dead on. But what if we had a piece that slid on the ways, came up above the center point, and had like a dial indicator up here, and you'd put your tool on, you'd have it below the center height, slide that over to where the tip of the indicator was right over the tip of the cutting tool. And we can change that position with this. So like, we're not going to be able to change where the indicator is because it's going to be riding on the ways, but I can adjust the position of the tip on the cutter, back and forth on this axis with this crank here. So we get it to where the tip of the tool is right underneath the dial indicator, and then we raise this with the height control until maybe it raises the dial indicator like a set amount, like maybe 0.100 of an inch. And then we lock it down and we know that's our center position. Let me know in the comments if you guys think that would work, if you got any ideas for that, or maybe even a better idea for that, or what other ideas that we could run with having these dimensions and already this design work done. And I read all the comments on these videos. Maybe at some point this channel might grow big enough that I can't read and answer all the comments, but I answer every single one of them now. If you guys have posted, for those of you that have posted questions and comments on previous videos, you know that. And thank you to those of you that regularly post comments on these videos. I really, really appreciate the conversation. So if you've got any questions about, this build process, even about the lathe, if you're interested in machining, or you've got other ideas about the potential piece that I just talked about, or other ideas for this, please post them down in the comments. Or even if you just want to say, what you thought of this build. I really enjoy reading your comments. Thank you. And if this is your first time on the channel, I do a new functional print every single Friday. Sometimes it's just something that adds functionality to some other tool that I've got or something in the house. Sometimes it fixes something that's broken. Sometimes it is a completely from scratch design that, is a functional, item for in the shop or around the house. If this is your first time here and you like that, consider hitting the subscribe button. And guys, if you do, I'll see you next Friday.